In algebra, we spend a fair bit of time working with binomials of a particular form, x plus or minus a number. And we saw in the last lesson how to multiply two binomials. Let's see if there's a pattern that we can use to multiply these binomials of this particular form that'll make life a lot easier, and that'll also set up the next thing we're going to do, which is factoring. So, x plus 1 times x plus 1. I'm going to show you what the final result is. You can do it using the method learned in the last lesson if you like, just to ensure that I'm doing it correctly. When you multiply x plus 1 times x plus 1, the final simplified product is x squared plus 2x plus 1. When you multiply x plus 1 times x plus 2, we get x squared plus 3x plus 2. When you multiply x plus 1 times x plus 3, x squared plus 4x plus 3. Now remember, we're trying to find a pattern here, so as this develops, see if you can spot the pattern. X plus 1 times x plus 4 is x squared plus 5x plus 4. X plus 2 plus x plus 2 is x squared plus 4x plus 4. X plus 2 times x plus 3 is x squared plus 5x plus 6. X plus 2 times x plus 4 is x squared plus 6x plus 8. Okay, moving on to a slightly different first binomial, x plus 3 times x plus 3, we have x squared plus 6x plus 9. X plus 3 times x plus 4, x squared plus 7x plus 12. Now, we've got quite a few here, and hopefully you've seen the pattern. So let's start with the end. These numbers in the final column, 1, 2, 3, 4, 4, 6, 8, 9, 12, how can we relate those numbers to the numbers that appear in the binomial? Well, in the first one, we have 1 and 1, we get 1. If you think of the area model that we learned last time, this corresponds to the bottom right-hand corner, which is just simply the product of 1 and 1. So these numbers represent the product of the two numbers in the binomial. And we can think of this as product right there, part of our pattern. So let's just check it's true. 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4, 2 times 2 is 4, 2 times 3 is 6, etc. So it's the same throughout, and we'll see some more that we can verify. What about the number in the middle? Now, if you recall, that simplified expression came actually from 2, the bottom left-hand corner and the top right-hand corner, using the area model. And so there's two expressions that are being combined. The two numbers represented in the binomials are 1 and 1 in the first. When you add them, you get 2. When you add the numbers 1 and 2, you get 3 for the second one. For the third one, when you add 1 and 3, you get 4, and that's the same all the way down. So this coefficient here represents the sum. And it's a coefficient because it's multiplying x in every case. So we have x squared is the same throughout all of them, plus the sum of the two numbers times x, plus the product of the two numbers. So now you have a nice pattern that will allow you to multiply two binomials very quickly. Now let's just verify that it works for a couple of more complicated binomials, bigger numbers, and throwing in some negatives as well. So x plus 5 times x plus 7. So according to the pattern, I said that this should be x squared. The sum of the two numbers is 12, so plus 12x, and the product of the two numbers is 35, so plus 35. Now if we go over to the right to the area model, top left-hand corner is x squared, top right-hand corner is x times 7, which is 7x, bottom left-hand corner is 5x, and bottom right-hand corner is 35. And sure enough, those four terms simplify to give me the three terms on the left, the trinomial on the left. The only simplification being the 5x and the 7x combined to give me 12x. Let's try it with some negatives. X squared is the first term. The sum of negative 3 and negative 4 is negative 7x. And the product, since it's a negative times a negative, is positive, so positive 12. So again, let's look at the area model. We have an x squared here, minus 4x, minus 3x, and positive 12. So these two terms along the main diagonal combine to give me negative 7x. So it works quite nicely. This last one should be the sum 5 and negative 2 is positive 3. The product of a positive and negative is going to be negative, and it's negative 10 in this case. So let's see what happens on the right here. This is x squared. This is negative 2x. This is 5x, and this is negative 10. And these two are like terms along the diagonal. They combine to give me my 3x. And so everything works out. So this pattern is really very useful for multiplying, but much more importantly, it's going to be very useful for factoring, which really means going in the opposite direction, and we're going to see that next.